Our next presenters are Dennis Krusac. He is the retired endangered species specialist for U.S. Forest Services. We also have Dr. Jackie Belwood. She is retired associate professor of biology for Georgia Highlands College. Today, their talk is called Anthropogenic Issues Affecting Bat Welfare. Thank you.
Thank you very much for inviting us to take part in this very important symposium. And we are going to be talking today about the anthropogenic effects on bat welfare, and with sincerest apologies to an Italian film director who had a film called The Good, the Bad, and the Ugly. When we were trying to figure out how to present this information, we figured out that the anthropogenic effects, really, we're going to be looking at the ugly, the bad, and the good, so be it. We should start off by talking about what we mean by anthropogenic. It's a term that's fairly old, and it refers to anything that is produced by or generated by humans. And that can apply to substances, processes, effects, et cetera, et cetera. Moving into the future somewhat, the definition has changed really to describe things that result from the influence of humans on nature. We're choosing for the purpose of this presentation to refer to environmental change. This is a US Geological Survey definition, that are caused by people either directly or indirectly. It's important to note that anthropogenic effects on the environment can be negative, neutral, or positive. And in the case of bats, they're going to vary depending on every aspect of a given species biology. That means that what affects one species may not necessarily affect another one. Why are we finding ourselves in a position where we need to talk about this? Well, of course, that has to do with the fact that since 1800, and we're projecting here to 2100, about 300 years, humans have increased from about 1 to 10 billion in just 300 years. And what we're going to be doing is tracking the effect of that on these wonderful animals here, recognizably in the fossil record more than 50 million years ago. If we look at the figure that is currently being presented, this projects population growth into 2100. And as we can see currently and in the future, the greatest growth is and will be in Africa and Asia. Of course, bats are not the only organisms that are being affected by human activity, to the point where we have now designated unofficially a new geological unit of time, the Anthropocene, which we can just describe as the time in the Earth's history when human activity has started to have a significant impact on the globe. Bat populations are declining, of course, which is why we are having this discussion. The IUCN estimates that about 80% of the world's bats require conservation or research. 15% are threatened globally. 52% of the species in the US find themselves in that category. And historically, in the past, all European and bats in the UK were on a downward spiral and protected since 1981 and 1991, respectively. Luckily, their numbers seem to be going up a little bit. The very sad thing here, unfortunately, is that we have no data for almost 20% of all bats globally. The figure on the bottom, right below the words, just shows what the situation is in the United States. Of course, this is the result of white nose syndrome and its impact on 5 species of bats since 2006. So we do have our work cut out for us. It's important to note, well, I'll get to that later. What is the scope of this presentation? Unfortunately, we will have a geographic bias for a number of reasons. Theoretically, we'd love to be able to speak about all species, but as was mentioned, we don't have data on so many. Also, there's a time constraint here in this presentation. And realistically, we're looking at the species for which we have the most data. This would refer primarily to what some people refer to as first world countries. So the US, Canada, Western Europe, Australia, Japan, etc. There is a lot of work being done in what some people call third world countries in the New World tropics, Southeast Asia, and in some parts of Africa, and there's less emphasis or less data on bats that occur in the second world. That would be more or less the communist bloc. All right, we're going to start off just by covering some bat basics. I realize that a lot of this has already been covered in presentations that we've seen earlier today and yesterday, but I'm just really going to highlight things that we can then bring back to anthropogenic effects. We want to make sure everybody's on the same page with regard to that. So of course, we're talking about the second largest order of mammals, the Chiroptera, so named from the Greek hand wing, because when we look at their wings, they are greatly elongated arm and finger bones, and they are the only mammals with true powered flight, flapping flight. They're worldwide in distribution because they can fly and have flown all around the globe. They are the second largest order of mammals. There are almost 1,500 species, which means that about 1/4 of all mammals are bats. I'd like to reiterate something that I said earlier today. There is no such thing as the bat, because with almost 1,500 species, there are about 1,500 different ways to be a bat. So what pertains to one may not pertain to another. Some generalities that we can make: bats have very low reproductive rates for animals of their size, mouse size, rat size, etc. And they make up for this by being long-lived. We've already talked several times in this symposium about the 41-year record of Branthyiotis. Most bats have one young, maybe two, and some can have 3, 4, or rarely 5. The important point here is populations do not rebound quickly after there have been major losses for one reason or another. Another important point here is that some bats can form very, very large groups. I'll talk about Tuderata brasiliensis several times, that the bats that live in Bracken Cave, Texas, about 20 million of them, are estimated to be the largest colony of bats anywhere. And again, this is a very old group. Things that are definitely recognizable as bats are in the fossil record and date back about 52 million years. There are 2 bat suborders, and I know we all know this: Chiroptera, also known as flying foxes or the old world fruit bats. There are about 200 species of those. The Pteropods, they're all in one family. They're in the Paleotropics, so Africa, Asia, Oceania, which are all those little islands in the Pacific Rim. They have a tendency to be large bodied, have large eyes, they do not locate, and they largely feed on fruit or nectar. The remaining bats belong to the supporter Microchiroptera, with about 13 species. As a rule, they are smaller bodied, they have smaller eyes, they all use echolocation to find their prey, find roosts, etc. So they're producing sound, which produces echoes, come back to the bat, and they basically see with their ears. These animals are worldwide in distribution, and they have very varied diets. However, about 70% feed on insects. We'll talk more about diets in a minute. But if we look at the global distribution of bats,
excuse me just a minute, Jackie. Could you get closer to the mic, because we're losing you?
Can you hear me?
I can hear you perfectly there. Yes,
okay, I'm not sure what the issue is, but thank you very much. Okay, so global distributions of bats, they occur from tree line to tree line. That's because they can fly tree line to tree line, because a lot of them are roosting in trees and they do need something to roost on or in. But as is the case with so many groups of organisms, we find the greatest diversity in the tropics. The numbers that you see on these species richness maps, or at least on the one on the left, are vague. They're just like generalized numbers. They're not hardcore numbers, but they do highlight the fact that the majority of bats are found in equatorial regions of the world, and not surprisingly where we've got tropical rainforests. In the United States, primary bat diversity species richness is in the southwestern US. But it is important to note, again, highlighting the Pacific Rim and Pacific Island areas, because that's where we find a very large number of endemics. And of course, endemics are things that only occur in the places where we find them. They're only in those areas, and they are vital to forest regeneration and economies on those islands. Now, a few more words about bat diets. Regardless of what they eat, they all provide very valuable ecosystem services. And as a rule, they have the most varied diets of any mammals. What a bat eats is a function of its sensory systems. That's echolocation, also use of eyes, scent, etc. Its morphology, where it is, the prey available to it. There are many, many different facets to this. 70% of them or so feed on insects, and those can be flying or ones that are picked off the surface. And again, that's going to be a function of the bat's sensory system, morphology, etc. But it's important to note that bats are top predators. They are at the top of the food chains in their local environments. They can eat their entire weight nightly, which is very important. When it comes to things like pesticides, they can really load up on those substances. And it's important to note also that seasonally, when insects become unavailable because it's cold, winter sets in, this can lead either to migration to warmer areas where insects will be abundant, or bats can get very fat, put on a lot of fat, travel to a cave site or another site where they can hibernate during a period of food shortage. About 220 species, and again, those are just general numbers, feed on fruit, and they can take up to 2 times their body weight every night, an enormous amount of food. And what goes in must come out. So if there are seeds excreted by these bats, small seeds like you see in the picture to the right of the words here, these animals are important seed dispersers, but it's important to note too that they may need to migrate, and many do, to follow food sources from one place to another. About 50 species feed on nectar and are very, very important plant pollinators, particularly in desert environments. And those bats too may need to migrate and follow food seasonally. Other food sources, which I'm not going to talk about here other than blood with vampires, are small mammals, birds, frogs, small lizards, fish, things like that. But it is important to note that there are 3 species of vampire bats. They occur in Central, I have a cat on my computer, Central and South America. Okay, so bat habitats. So we're talking about places where bats roost and where they can forage, just sort of as broad categories. And these can be very varied. We could consider these ecosystems too. We're looking at most forest types. That's it. Deserts, urbanized areas, agricultural areas, pretty much just about everywhere. I'm going to highlight islands again because Frick et al. Really highlighted them in a seminal paper they did on bat conservation, and really highlighting the fact that bats on islands are extremely vulnerable. So we're kind of putting those in a category on their own. The use of bat habitats can vary seasonally, and by seasonally, we can mean temperature differentials between winter and summer, or between wet season and dry season, or some bats may move to an area for reproductive purposes. For example, the bats in Bracken Cave in Texas are there for about 6 months of the year. They go there from Mexico and they use Bracken Cave as a maternity site, usually females only. So of course, this transition between different habitats can involve migration, and sometimes those migratory trips cover great distances. Good examples of that would be the straw-colored fruit bats in Zambia, which travel a great distance. You can see the figure to the right of the words that are there. And then to the far right, we see the distance, sometimes more than 1,000 miles or 1,600 kilometers, traveled by hoary bats from places in the southern United States to Canada. When it comes to roosting sites, again, very, very varied. Trees are supremely important. And when it comes to trees, the older the better, because old trees have cavities in them, nooks and crannies. They have bark that can be peeling away from them, and those can serve as roosts for single animals or small groups. If the bats are fairly small, you can have several hundred bats that are in a tree cavity. Other tree roosting bats will roost out in the open in foliage. Some of them are single, some of them form small little groups, or on the other end of the spectrum, we have the very large camps of flying foxes that are so familiar in Australia and in the Pacific. Bats will also roost in naturally occurring landscape features, things like caves, and we'll talk about caves a little bit more in a minute, cliff faces, and they can also roost in man-made cave-like structures. So these are sort of, they turn into bat roosts, but these are unintentional roosts because they weren't intended for the bats. And that would be things like abandoned mines, bridges, and railroad tunnels. Also, some will, they're very opportunistic, roost in buildings and other man-made structures. But then, of course, some of them will roost in structures that were intentionally built for them. So that would be our man-made bat houses. So again, we can't talk about bats without talking about the importance of caves. These are among the most important roosts for some species. They're used by about 50% of all bats globally. And they're important because they provide a secluded environment, usually at critical life history stages for whatever species is roosting in them. They can serve as mating sites for some species. It's where young may be born of other species. And in some cases, we've already mentioned this, they are hibernation sites. These sites are important because what they do is they provide species-specific microclimates for the different bats. This is a generality, but cave temperatures, microclimates, so we're talking about temperature and humidity, have a tendency to approximate yearly average above ground conditions. But of course, you can get microclimate pockets in caves. And what we find is that some bats return to the same handful of caves over and over and over again. They're the only places they go to, save for hibernation. So these structures are critically important for the bats. They don't have other places to go to hibernate. And of course, the big question here is how will climate change affect all of this? Mentioned this already several times, but some of the world's largest bat colonies are in caves, Bracken Cave, Texas. And then in Borneo, there are several large caves in the Mulu National Park. Caves offer a wonderful opportunity for conservation if they can be protected, but of course they can't all. But also on the flip side of that, large colonies can increase the potential for mass die-offs if there's vandalism or if there is disease. Now, we said we were going to talk about the good, the bad, and the ugly. So let's start talking about some of the uglier aspects of some of the things that surround bats, some of the negative anthropogenic effects. And I put this in here, it's not so much ugly, maybe it's really more unfortunate. And that's the fact that we know almost nothing about so many bat species. About 25%, there's been an increase of about 25% in the number of bat species in the last 15 years. And it's guaranteed that we know almost nothing about any of those. Even the species that we know best, there are still so many things that we do not know about them. This is all compounded by the fact that bats are nocturnal. They're active at night. Most researchers and people are active during the day. They're very secretive and they roost in inaccessible places like high in trees or deep in caves. They're very sensitive to disturbance. If you mess with a bat roost too much, the bats will just up and leave, which means you can't study them anymore. And then if one goes to tropical rainforest environments, the complexity of those environments makes it almost impossible to, get a good handle on what is going on with all the bats that may be residing there. Sadly, many of those areas in the tropics are also the places where there's inadequate research funding for basic studies on bats. Bats, of course, fly too often over very great distances, which makes them very difficult to follow. And so many species are cryptic. Basically, you can't see them. They're small, they're dark, they're hard to see. Again, that makes them very difficult to study. And even though some bats are very vocal, we can't hear their calls or the calls of many of them because they're ultrasonic, and this is going to require very expensive equipment to be able to study them. Data deficiency with regard to bat species is particularly acute, again, in those areas in the tropics where bat concentrations are the highest and where populations are now growing the fastest and will grow the fastest in the future. Sadly, some data deficient species likely require immediate attention, like right now. Gray flying foxes in Indonesia come to mind in this regard because they're facing extreme hunting pressure. But again, it's very difficult to get a handle on how to deal with many aspects of them. All right, some of the other ugly stuff that we can associate with people and bats are all the myths, the negative folklore, superstitions, and misinformation that's associated with them. We've all heard this. Bats are dirty and disgusting creatures. They're flying mice and rats. They fly in your hair. They attack innocent women and children, suck blood, transmit diseases. And then there's a lot of misinformation in areas of the tropics where we do have all the pteropodids. There's a fear of crop depredation by these fruit bats. And again, that's information that it is misinformation. And some people just don't like bats because they figure they're active at night and nothing good should be really active at night. It's easy to laugh off some of these myths and superstitions, especially in North America, where you have the media sort of, very much involved in here. But eradication campaigns and removal campaigns related to the fact that people don't like bats or are afraid of them or have misinformation have very serious repercussions. In the US, for a long time, this was fueled by the media and pest control operators. In Europe and the UK, this is really more historic than current. It was fueled by renovation of old building structures. People got rid of all their bats because they wanted to renovate buildings. In Latin America, it's indiscriminate eradication of diverse bat communities for vampire bat control. There's one example I can recall where there are 12 species of bats in a cave, and I think vampires may have been there, and the entire caves were wiped out. And of course, these are bats that are pollinating plants and dispersing seeds. In various parts of the paleotropics, there are many means to dissuade bats from being in for attack from depredating crop plants. So some of the methods used: electrocution, netting, shooting of things like spectacled and gray-headed flying foxes. The regulatory protection for this, whether you can do it or not, varies greatly. For example, there's complete protection in some areas like the UK, and then on the other end of the spectrum, we have no protection at all in other areas. Again, sometimes it's easy to kind of laugh all this off as just sort of being silliness and nonsense, but the repercussions can be serious, very serious, when there's intentional disturbance and destruction of caves, for example, in bats. Vandalism is not uncommon. This is a very disturbing photograph on the right. I hate bats, along with a satanic symbol. And again, bats are very vulnerable because they are forming large colonies in these structures, and their survival depends on the various cave features that have made the caves so important to the bats. Many of these caves do contain endangered species. And again, as I mentioned before, some of them can be protected. Some environments are unintentionally disturbed by recreational cavers, the effects of landscape level fires and floods, and then of course in many parts of the world where there's civil unrest, instability, war zones, etc., that populations are being affected. Poaching, hunting, and over-collecting are also very important negatives. About 170 species of bats worldwide, so that's about 13% of all our species, are hunted for food, medicine, or sport. Sadly, bush meat hunting is increasing in Southeast Asia and West and Central Africa. And again, those are the areas where we see the highest bat diversity and also the largest, or the potential for the largest increases in human population. Poaching and hunting disproportionately affects pteropodids that are over 1,000 grams. And sadly, only about 71% species of those 170 are listed on CITES appendices that prohibit or control trade in these organisms. Recently, we're also seeing a lot of over-collecting as a result of zoonotic disease studies. I had to throw this picture in here, or this slide in here, because I was so maddened by it. Bats, taxidermy bats are unfortunately very common in the US around Halloween. And the bats that are being picked off for this. Carivalo picta, because it's a Halloween bat in the US, orange and black are Halloween colors. And I looked these up in preparation for this talk just last week, and was really saddened to see that these things are being advertised as being farm raised. And this is text taken right off the internet, or non-protected species. Okay, the bad. We'll switch speakers now.
Okay. Habitat loss and destruction is the #1 cause of bat declines globally. It can be separated into two things. Habitat loss is basically temporary, things like forest regeneration or the effects of a forest fire. Habitat destruction is a permanent loss of habitat, things like deforestation, urbanization, road construction, guano mining in caves if it alters cave microclimate, and blocking mine entrances. As an example, from our own backyard in Atlanta, there was no planning. It's too late for us. In the early 90s to 2000, during the housing boom, we were losing 54 acres of green space a day and gaining 28 acres a day of impervious surfaces, rooftops, driveways, parking lots. So over a 10-year period, we lost 200,000 acres of green space and gained 100,000 acres of impervious surface. And it's estimated by 2030, 3.2 million acres in metro Atlanta will be impacted by development. If we move on to the tropics, during the peak clearing, we're losing 125,000 acres a day. In Brazil, between 1990 and 2010, they lost 143 million acres of forest, which is equivalent to the area size of Maine, New Hampshire, Vermont, New York, Connecticut, Rhode Island, Pennsylvania, New Jersey, Delaware, Maryland, West Virginia, and 2/3 of Virginia. And sadly, the loss is probably even greater today.
I just wanted to bring up the issue of agaves that are used to make tequila and that are pollinated by lesser long-nosed bats. And I usually bring this up in talks because so many people really like tequila. It's a way to grab them in and get them interested in bat conservation. It's important to note that for more than a century, the tequila industry was preventing agaves from flowering so that they could increase the sugar levels in agave heads. And that's, you can see a man there, and he's got a big white bundle there. That's the agave head. And that's what's used. It's fermented to make tequila. When this is done, when the plants are not allowed to flower, it deprives the bats of food. And happily, there are biologists at UNAM, the Universidad Nacional Autónoma de Mexico, Rodrigo Medellin in particular, who's working with agave growers to leave some agaves, about 5%, to flower and produce bat-friendly tequila. Climate change is another really important issue. We know it's here and we know it'll worsen. And it's not just global warming, increased heat, but we're also looking at drought, severe weather events, hurricanes, untimely cold weather, fire, and many other things. It's estimated that about 82% of North American bat species will be affected by climate change in the next 15 years. And I just have some examples, some of the pictures there. You can see Cyclone Pam in 2015 in the lower photographs, Hurricane Katrina in the upper one, and then just a couple of months ago in Australia when temperatures were above about 45 degrees Celsius. These effects, as we can see, are global, and they are going to affect bats worldwide. And again, the fewest data are available for the areas in which we have the highest bat diversity, where we have the highest bat diversity. So right now, the only thing we can do is make predictive models. And again, highlighting again that island populations are particularly vulnerable from things like cyclones. How does climate change affect bats? Well, we can look at, first of all, just direct physiological effects. The picture on the top right shows something that happened in Cairns in Australia in 2018, when it's estimated that 30% of spectacle flying foxes were lost when temperatures rose above 42 degrees Celsius. So this is just direct physiological effect. It's death. There are other studies that have shown long-term lowered reproduction in some species, and one paper I highlighted but don't have a reference for was for the European Tidarida. Also, we'll find that there's alteration of cave microclimates, potential for flooding of caves, and flooding of caves has killed a large number of bats in the past. There are also changes in insect, flower, and fruiting phenologies, and the result of this will be temporal mismatches with bat activity. Bats show up in an area expecting, say, agaves or saguaros to be flowering, and they will not be. Range changes are likely of both bats and their food, and it's very likely that bats, many species will have their migratory events disrupted. They'll spend less time in torpor, and it will also affect birthing dates and development of the young. Another really important thing to talk about is the use of pesticides. Enormous quantities of these pesticides, and that includes insecticides, fungicides, and other forms of pesticides. About 1 billion pounds, 450,000 metric tons are used annually in the US. Globally, the number is about 5.6 billion pounds or 2.5 million metric tons. The worst offenders here are Asia, 53%, followed by the Americas, 30%, and the numbers on the left correspond to the figure that you see on the right. Bats can be exposed to pesticides in a variety of different ways through direct skin contact, inhalation after an area has been sprayed, on their food, which might be particularly important for fruit-eating bats, also for insects, and through water. Sadly, many pesticides persist a very long time in nature. And as I've already mentioned a couple of times, these can concentrate as they move. I didn't mention it, but these pesticides bioaccumulate, and they will concentrate as they move up a food chain, and insect-beating bats, again, are at the top of their respective food chains. Sadly, the effect of pesticides on bats has been very poorly studied. Direct effect, just a couple of examples. DDT sprayed in little brown roots. This goes back to the 1970s, will kill them outright. In Europe, historically, many bats died by timber treatment chemicals used to fix up wood that had rot and whatever it is in older houses. DDT has been found in bat colonies more than 40 years after that chemical was banned. And more recent studies are showing high concentrations of pesticides in dead bats in New Zealand and Spain. Sadly, when there are bat die-offs, there are not very many researchers who are doing toxicological studies to see if pesticides are involved. And I think that we really need a big change in that regard. Indirect effects, pesticides also affect insect populations, and we see massive insect declines in some areas. As most people probably know, insects are the world's most abundant and speciose animal group. The number of insect species out there is not known. It can range from 10 million to 100 million different kinds, especially when one looks in the tropics. And what we do know is that global insect populations are declining. This was first noticed in the 50s and 60s. There's a great review paper. It's actually a very sad read that highlights the demise of these organisms. And they predict, the source is on the bottom, the link, that about 40% of insects will go extinct in the next few decades. We're losing about 2% a year. And they highlight the causal factors there, and the use of synthetic pesticides and fertilizers is number 2. Pesticides affect different insect groups to a different extent. High on the list of affected species are butterflies and moths. Of course, moths are a very important source of food for insects, and other species that are affected very much are ones that they undergo their larval development in water. So that would be things like caddisflies, mayflies, chironomids, midges, things like that. And those are also very, very important prey species for many bats.
Okay, switching gears, talk about wind turbines. Globally, more than 1 million bats are killed annually at wind-developed sites. You can see the numbers there: 800,000 in the US, 200,000 in Germany, and 40,000 or so Canada, Australia. That's just one state in Australia. I only looked at 4 studies, so it's well over 1 million bats killed annually globally. The fatalities are primarily long-distance migrants in late summer and early fall. There are higher fatalities on low wind speed nights, and these events are also often associated with approaching storm fronts. Now, this is a good bad situation here. The energy capacity expected to increase 500% by 2050. At the rate we're killing bats, there may not be any left, but when we start talking about some of the mitigation later on the good, we may put this in perspective. The 3 most affected species in North America are the hoary, eastern red, and silver-haired bats. Hoary bat populations could decline 50% by 2028. That's only 4 years from now. And hoary bat fatalities are so high, the U.S. Fish and Wildlife Service is undertaking a discretionary review to see if listing under the Endangered Species Act is warranted, with a decision date late in 2027. Another key factor affecting bat populations is white nose syndrome, first observed in Howe Cave in New York in 2006. It's a new emerging disease, which is basically a disease that appears in the populations for the first time, or it may have been there previously, but is rapidly increasing in incidence and geographic range. And it gets its name from the appearance of white fungus on the muzzle of the body part and other body parts. The causative agent is Pseudogymnoastis destructans, a cold-loving fungus. It's spread to 40 states and 8 Canadian provinces, which you can see here. In addition, the fungus has been detected in California, Idaho, Louisiana, Alberta, and British Columbia. And those are probably going to be the next 5 locations where white nose syndrome is clinically diagnosed, because the pattern historically has been that the fungus is identified 2 to 3 years before the clinical diagnosis of white nose syndrome. And it's also anticipated to invade Mexico, where some of the bats hibernate in caves. In North America, 12 species have been confirmed with white nose, 10 of which are myotis. 3 of those are endangered species. The tricolored bat is proposed endangered because of the effects of white nose. And little brown bat, the Fish and Wildlife Service will make a listing decision by the end of 2024. And if I was a betting man, I would bet that the decision is proposed endangered. There's 8 additional species or subspecies in which PD has been detected. That includes the 2 endangered subspecies of Coriorinus townsendii. Mortality rates for some species exceed 90%. Most recovered dead animals are in poor condition, in poor physical state. The photo on the left is not a bunch of roosting little brown bats. That is a carpet of dead bats on the floor of Aeolus Cave in Vermont. And the others just show bats out in the dead of winter trying to find food as they starve to death. There is a European connection. There's a similar fungus from European bats that's being studied. It's genetically identical to the fungus in the US. 2 different ideas of how the fungus got here. The caving community suggests that it was a stowaway bat in a shipping container that somehow miraculously found its way to Howe Caverns up in New York. Another people believe that it was either a European caver coming to Howe Cave with gear that wasn't disinfected, or an American caver going to Europe and coming back and going to Howe Cave. And there's some evidence that shows that's probably more logical, because initially on there were some long distance dispersals of white nose, and those are all to highly popular recreational caves with low bat abundance. There is no mass mortalities occurring in Europe, and we don't know whether that's the result of mass die-off hundreds or thousands of years ago, and now we're looking at those that have developed a resistance or not. And the fungus disappears from infected bats after hibernation. 14 species in Europe and Asia are confirmed with white nose. 8 of those are myotis. An additional 7 species have been confirmed with the fungus. And again, 4 of those are myotis. So the myotis genus seems very susceptible to white nose syndrome. So we're going to talk about the good.
finally some good news. Yay. Okay. I think probably the thing that just struck me the most when we were putting together this presentation, because I think I knew this, but I hadn't really thought about it. You know, when you write things down, you kind of see things in a different way, is that basic research on bats is at an all-time high. And when we're talking about basic research, I mean things like, you know, basic geographic biodiversity studies when we go out, get basic like history information, weigh them, sex them, you know, find out when they're reproducing, record them, get swabs for genetic analyses, and try and determine as much about their ecology and physiology as we can. Trying to make this a little bit more personal. When we were putting this together, I just started looking at some numbers of participants at various bat research conferences. The 19th International Bat Research Conference, which was held in Austin, Texas in 2022, had over 600 participants. I don't remember how many countries were represented, but if you compare that to the 5th International Bat Research Conference, in 1978, there were only 217 participants. I don't know how many papers were presented there. Gainesville, Florida, which actually is where Dennis and I are right now, has hosted NASBR twice. That's the North American Symposium on Bat Research. And in 1977, we had 110 participants and 46 presentations. In 1993, when Luby hosted, we had 231 participants and 96 presentations. Gainesville is putting in a bid to host it again in 2027. That would be NASBR, sorry about that. And right now we're trying to find a hotel that can accommodate about 400 people, because that's what we expect to show up. It's also wonderful that the diversity of researchers has increased greatly in the last few years. More than half the presenters and attendees at these conferences are women, and every year there's more and more representation from every part of the world.
All right, switching again. I'm going to talk about some of the applied research dealing with white nose syndrome. We'll start off with volatile organic compounds, and underneath there you see a little bit that says, don't pass up on lunch and learn. It was interesting. I was invited in 2009 to present at a lunch and learn for grad students at Georgia State University in the sciences to talk about a pollinator project we were working on. And there was a PhD student presenting on a project he was working on using volatile organic compounds to inhibit fungal growth on fruit. And it was an amazing presentation. And after his presentation, I asked him if he thought it would work to control the growth of the fungus that causes white nose syndrome. And he said he didn't know, but get me the fungus and we'll find out. And we did. And sure enough, these volatile organic compounds did inhibit the growth of the fungus that causes white nose syndrome. So that really changed the emphasis on where people were looking. Other things that are being looked at to fight white nose syndrome, polyethylene glycol 8000 and ultraviolet light are used to treat substrate, and we're testing those in mines rather than in cave systems, because we don't know what the effects will be on the native cave flora. Other things being investigated are vaccines, anti-PD probiotics, which are placed in bat houses during the summer, so they've got those probiotics when they go into hibernation. Hibernaculum cooling, basically getting hibernacula colder than the optimal growth for white nose in caves. Fat bat, this is a BCI project using ultraviolet light near hibernacula entrances to concentrate prey to increase feeding efficiency. So the bats are going into hibernation fatter. And then bat box enhancement and gene silencing. When we look at some of the research with wind energy, there's blanket curtailment. That is altering turbine operation based only on wind speed. And if you increase the cut-in speed, the speed at which energy is starting to produce to 5 meters per second, it reduces overall bat fatalities by an average of 62%. Basically, what they're doing is feathering the blades, putting the blades parallel to the wind so that the blades don't spin. Smart curtailment, in addition to wind speed, considers temperature, nocturnal timing, bat activity, and wind direction. There's been very few studies that have looked at these variables, so it's hard to make any conclusions. Other things that they're looking at are deterrents, both acoustic and ultraviolet. And this is basically still in the research and development stage. And if you're interested in bats in wind, I would encourage you to go to the Bats and Wind Energy Cooperative website. They're the ones that are spearheading most of this research on the effects of bats and wind. And all of their webinars and everything else are posted on that site. Other applied research dealing with forest management, looking at prescribed fire, the frequency, intensity, and seasonality of burns and how that influences clutter density and snag creation, all of which will affect what bat species use those habitats. They're looking at the effects of timber harvest, various harvest techniques such as clear cutting, shelterwood, seed tree, group selection, single tree selection, and thinning, as well as patch size, aspect, whether it's a northeast, south, or west facing slope, as well as slope position, whether it's at the toe of the slope or at the ridge. Most of these roots, at least in the southeastern US, on an upper third of the slope with a south or southeast facing aspect. And based on all these various conditions, it will influence which species utilize these habitats, and also invasive species control. Other things that are being done with the research is occupancy modeling, which is basically predicting where bats may be based on past occurrence and habitat variables, which allows managers to prioritize where to implement projects. It refines where to conduct surveys. And it also highlights areas to avoid where there's a project that's likely to have an adverse effect. A lot of research going into bat houses in design, size, color, and location. A 2023 publication, Best Management Practices for Use of Bat Houses in the US and Canada. It's available on the whitenosesyndrome.org website. It's probably the best publication out there if you're interested in bat houses. Now we're going to switch and talk about habitat preservation and management. We look at public lands. We're talking about national, state, provincial, county, and local forest parks, refuges, and preserves. And those national things, talking about national forests, wildlife refuges, national parks, BLM lands, Army Corps of Engineers, Department of Defense, and in Canada, the Parks Canada. Those national, state, and provincial lands provide large landscapes for conservation. We need to consider industrial forest lands. They're often large holdings and often near public lands, creating larger landscapes for conservation. And private lands are critically important to conservation, particularly in areas with little public land, which is basically, if you're in the US, anything east of the Rocky Mountains. They can serve as linkages to public lands and are extremely important in urban, suburban areas. Habitat corridors, these are strips of land that differ usually in terms of dominant vegetation and ecological condition. They're basically avenues for wildlife species to travel in similar yet fragmented habitats. They provide food and cover for as many species as possible. And I want to highlight the second one from the left. That is an orangutan buffer between oil palm plantations in the Borneo. And then the far right, we believe is an inadequate riparian corridor because something that narrow is not going to protect water quality or provide much habitat. Just quickly throw out an example of what the U.S. Forest Service is doing. They just completed an Eastern Bat Conservation Strategy driven by white-nosed to conserve Indiana, northern long-eared, little brown, and tricolored bats on 25 million acres of national forest lands in the east, which you can see depicted there in the green on the map. It was developed collaboratively between the Forest Service and Fish and Wildlife Service based on the best available science using an adaptive management approach. It's basically managing at a landscape level approach, ensuring connectivity of habitats, vegetation management primarily through timber harvest, use of prescribed fire, creation and management of forest openings, snag and hazard tree management, control of non-native species, managing riparian zone, and mitigating white nose syndrome. The basic components deal with habitat protection around hibernacula, which I'm going to skip through this for the sake of time and go to this diagram. There's basically three buffer zones based on population size. The primary zone is always there regardless of population size. It's a 500-foot radius to protect the cave microclimate. And the secondary and tertiary buffers would be implemented based on abundance within the hibernacula. So hibernacula with 30 bats in it is not going to have a primary or secondary buffer because there's not enough bats to need that habitat. And the restrictions within those buffers decrease the farther you get from the entrance. It's important to protect roosts. We want to provide practical and achievable conservation actions to protect known or suspected roosts and encourage the protection and recruitment of potential or existing and new roosts. And we're talking about suspected maternity roosts. That's any post-white nose capture reproductive female or a juvenile between May 15th and August 15th. Because if you've got either one of those, there's a maternity roost, even though you don't know where it is. And this diagram showing that you've got your known roosts provided the primary buffer, which is 150 feet to protect the integrity of that roost tree, a secondary buffer varying in size depending on species to protect the presumed core roosting area, and then the assumed foraging area around that. I'm going to switch back to Jackie.
All right. Other positive things that we can do to help promote bats. We can try and protect important natural bat roosts. Primo examples, again, Bracken Cave, which was purchased by Bat Conservation International in 1992. Lower diagram picture on the left shows a lesser longnose bat cave in Mexico. And again, as the result of the work of Rodrigo Medellin and his associates and educational campaigns, these caves, darn it, have been protected and have now taken these bats off the endangered species list. When it comes to important hibernation sites in caves, we can erect cave gates. This can be done on private or public lands, excluding visitors, but allowing the bats to use these sites. Downside of this, it's not easy, it's not cheap, and it's also really important to have educational campaigns associated with cave gating, especially if the caves are used by cavers. We've had a big hubbub to do in the United States when some caves on Forest Service properties were closed as a result of not wanting to spread white nose syndrome, and cavers were not very happy about this. It's important to note that not all bats will tolerate caves. It's important to protect other natural roosts, old trees, and cliff faces, but equally important is the protection of unintentional or man-made bat roosts. These are ones that bats opportunistically have chosen to colonize. That would include abandoned mines, as we see on the left. They can be gated, and structures like bridges. This is the Congress Avenue Bridge in Austin, Texas. Some of you may be familiar with it. It's home to 1.5 million Mexican free-tailed bats for about 6 months of the year. And these bats were slated for extermination in 1986. An educational campaign by BCI saved the bats from being exterminated. And today, 100,000 people come to Austin to see the bats, and this adds about $8 million to the local economy. Dennis has also talked about the construction or installation of small bat houses. This is a popular thing to do on private land around people's houses. All you need to do is Google the internet and you will find many sources of bat houses or plans to build your own. These are useful structures because they can help mitigate the loss of bat roosts. And in a neighborhood, they can start discussions about bat conservation. It's important to note that there are many, many designs out there, and the rule of thumb should be to choose ones that adhere to best practices. And again, as Dennis did, I would point you in the direction of the best management practices for the use of bat houses. The construction of large bat houses, this is also an option. I'll highlight on the left here 3 bat houses, very large bat houses that were built on the University of Florida campus in 1991, 2010, and 2017. Originally, the house to the far right was built to house 5,000 bats that had taken up residence in a sports stadium on the University of Florida campus. And since about 1995, that colony has grown to between 400 and 600,000 individuals. If you have a lot of money, the land, and the inclination, you can build your own chiroptorium, as David Bamberger did at Blanco, Texas. This is a structure you can see. I don't have a pointer that I can use, but you can see the, do I have a pointer? The structure here to the right that was built. This is an artificial cave that he built on his property, which is now home to 500,000 Mexican free-tailed bats. This was built in 2003. It's important to note, especially with the audience we have here, the importance of education and outreach programs. And of course, that is a very positive thing that people can do about bats. There are many programs out there. They're hugely important and they're becoming more and more popular all the time. When I first started doing bat conservation programs in 1979, I'll never forget this. I was supposed to give a program at a nature center here in Gainesville, Florida. It was highly publicized. Nobody showed up. Afterwards, when I would show up anywhere to talk about bats, I got the same negative, myths and superstitions. When I see what's going on now, all the programs that are out there and all the people who take part in these, it can be in-person programs, just using printed materials, the internet, and of course, as Brian Pope highlighted, the importance of social media. It's really astounding to see how much things have changed with regard to bats and education. I think it's really important when giving bat programs to impart relatable information. And that could be the role in pest control, pollination, tequila, if you think your audience is into that, seed dispersal, and all the vegetative products we have as a result of tropical bats in Okay, so I'm going to probably skip to the final slide here because we're getting to the end. Education for specialized groups is necessary, like pest control operators. It's important to include kids in these programs, and also has been highlighted in several publications, social scientists who can evaluate if we're doing a good job. I'd just like to give a shout out here to bat sanctuaries, zoos, rehab facilities, and associates for all the great work they're doing. They're listed there. I know my husband is telling me I keep moving. Thank you for all you do. All the other research and educational facilities and venues, all the researchers and educators, zoos, museums, nature centers, and science centers, and of course also all the bat NGOs that are out there, and there are many. Okay, so into the future. Surge in bat popularity and the number of professional volunteers and members of the public who take part in bat conservation and interested in it should give us hope for bat conservation, that we can achieve a goal where we can live in harmony with bats and other wildlife. However, given human population surges, habitat degradation, and many of the other things that have been spoken about in this presentation, it's likely that we are going to have a very much growing need for collaborative research, monitoring, and public support for bats. The conservation of bats will require sustained efforts and funding to address data deficiencies, information, first of all, on population status and trends, and global bat conservation will also require the integration of research and conservation to identify stressors, the things that are affecting bat populations and their solutions. The formation and support of global and regional networks that connect researchers, conservationists, educators, and local stakeholders who work to conserve bats is a must. I would draw your attention to this incredible book, Bats in the Anthropocene, Conservation of Bats in a Changing World. If you're not already familiar with it, it is an open source book and it's available for purchase on Amazon also. And I believe that's it. Oh, no.
All right, quickly, things you can do to help bats. Put up a suitable bat house, join a bat conservation organization, support land trusts for habitat acquisition. If you own acreage, consider putting it under conservation easement. Reduce or eliminate pesticide use. Don't cut down dead trees in your property if structures aren't at risk. Support renewable energy development. Get involved in presenting bat conservation education programs. Volunteer with wildlife management agencies to help with their bat monitoring programs. I want to thank you. I know we've eaten into your break. Apologize for the technical difficulties early on. There's our email addresses. We're both retired. We have plenty of time. Shoot us an email if you have questions, and thank you.
Okay, thank you, Dennis and Jackie.